There you go. Hi, hi, how are you? Everybody, welcome, welcome. Hi, hi, nice to see you, nice to see you. How is everybody? Good? Fine? Super awesome? Babileto is here. If you have no idea what Babileto is internet, I'm sorry. A Czech thing, you can search online. But we are gonna have today our class about detecting intruders in your server. So welcome everybody, welcome internet. We have a nice class today. It's gonna be one class completely dedicated to defensive side. So today we are defending. If you remember last class, we are attacking, exploiting, getting in, execution of commands, Apache, and stuff like that. If you are playing in the Strato Cyber Lab or you are playing in the assignment, you know that this is what you are doing. Today, we are taking the step into the defensive side, okay? Which is much, much harder, actually. And yeah, that's part of the imbalance of cybersecurity. So, the one where we catch them red-handed, this is this one, October 17th, 2024. We have all our links. We have some changes in the links. Now the intro sound is a direct bit.ly for you. And I'm going to zoom in for the results of the last class survey. How was the class tempo? And the majority say it was all right. So it was a nice improvement. For some of you, it was still too fast. But I think it's expected with all the people who have in the internet. Some people is still going to be too slow or too fast almost every time. How well could you follow what the teacher explained in class? I have 10s and 9s and 8s and 7s, some 5s and 6s, stuff like that. So far it's expected because it should be a small challenge for you, right? If you are taking this class and there is no challenge for you to learn new things from commands to terminals to timing to paying attention, well, there is no learning. And I wanted to say at the end of the last class for the people in the internet that we know this is very hard for you, that being at home or at work or in the street and having 3 hours per week continuous 3 hours per week to watch this class is very hard. And we know that from a lot of you, you just have 1 hour and then you finish in the weekend or you do in parts. So being focused and being dedicated to this is a hard job. So thank you very much for the effort. We believe it's worth it that having this class, especially if you are not taking university classes, it's going to be feeling a little bit too much sometimes. It's going to be feeling a little bit like fast. That's okay. That is pushing you to learn faster and better, okay? So then we have Pioneer Prizes for assignment number 3. Pioneer Prizes are here. We have competitions, a lot of people competing. Sometimes we are very impressed, people. It's like, oh, we are gonna start the assignment, and then 4 minutes later, there is a solve. You say, whoa, was fast. Somebody was very ready. So the first place is going to be a Seed Studio Xiao ESP32 device. Very small people. This is new stuff. The second is going to be an RFID reader with an antenna. That is crazy nice, too. And the third one is going to be a USB 2 isolator to protect whatever you connect to your USB computer. So the third place goes to Fabian Bodonafa. Bravo, Fabian. Gratuluju, gratuluju. There you go. Well done, well done. The second place, it's gonna go, I don't know how to change this. Okay, yeah, there you go. The second place goes to Dominic Nguyedon. Bravo, Dominic. Bravo, bravo, bravo. Well done. And the first prize position goes to Lukasz Kaumlufwan. Bravo, Lukashi. Bravo. Well done, well done. And remember that every time there is an assignment, there are many things to solve. So you have to solve them all to actually finish, right? So don't get discouraged if you see somebody finish finishing some of the stages fast, because you have to finish all of them, right? So there you go. If you have questions about this, because you didn't solve it, you can contact us, remember, privately, and we can talk about this, okay? And keep trying, people, keep trying. Like, it's very nice to play this and to speed up, because you are out of your comfort zone, and then you have to do stuff fast and type fast, and you have no idea what you are typing. That's part of the training, to give you this unknownness, pushing stress that you have to do something very fast, okay? So it's a nice experience. Go and try. So there are 3 main topics for this class: how to find out if someone got into your computer, then how to secure your computer, and then we are going to be doing a little bit of host-based intrusion detection system, okay? So let's start with protection in computers is about layers, okay? All protections is about layers, and layers like an onion, not an ice cream. If you don't know what I'm talking about, if you don't know this movie, I don't like you again. Just go and watch the movie or search like onions, not ice creams. But this is exactly what it is, protection. So the goal is to understand how to protect a computer, to know how to find if there was an intruder inside a computer. And this actually happens almost every day that you are checking. You log into your computer, you have no idea what happened. So you need to do some checks usually. What do we mean with a layered approach, these layers of security? So assume all other protection measurements fail. This is the first assumption. You should approach this like everything failed. You had firewall, antivirus, humans. This is the first condition. Believe that everything fails, and whatever you are setting up in that moment, that's going to be the last one. Are you putting permissions? Are you installing software? Believe that you are going to be the last protection, because this usually happens. Do not rely on, oh no, we have a nice antivirus. This is not going to happen, right? Separate your defenses so they don't depend on each other, right? Try not to have dependencies on, I don't know, updates and backups on the antivirus or in something on the firewall. Protect every aspect you can think about. So really think out of the box, like, right? What about this? And then, you know, think about some you didn't think, because that's why the people get in. And usually we separate the approaches in, protect the data. That means encryption, hiding, backup, whatever, destroying. Then protect the application. That means update the application, maintain, check the logs, the processes, right? Then protect the service. That means the database, the load balancers, right? Then protect the complete endpoint. That means the firewall, the users, the authorizations. And then protect the connections, Wi-Fi, networking, cables, Bluetooth, whatever you have in there. And finally, protect the humans, right? Teach them, go and evaluate the phishing campaigns, right? Like, try to make this happen. So this is what the community for the last maybe 3-4 years, they called the zero trust thingy, the buzzword of, oh yeah, we do zero trust. Well, it means this. It means do not trust any part, okay? So how to find out if someone got into your computer? The first thing to know is that every time you got into a computer, it's very, very, very hard not to leave any trace. This is very hard, people. Like, you go into a computer and you're going to leave some traces. So your job today is to find those traces, okay? And there are many things, right? The attackers can get in using SSH, but also an exploit or a backdoor. So there are so many things, so many ways to do that, that it's very hard to check them all. So let's start by looking first at the logins with standard methods. And when we say standard methods, we mean the official way somebody can log in a computer, like SSH, Telnet, SMB, NFS, FTP, or whatever, okay? Other non-standard methods are, well, methods put there by the attacker, like backdoors, exploits, stuff like that. Those are not going to be recorded by your system easily, okay? So first command of the day, go to your Dockers, please. I'm going to try to go to my Dockers now. I'm going to make this bigger. There, something like that, let's say. And this one also, go, 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 go. Oh, there you go. So the first command is going to be W, okay? Also in your Strato Cyber Lab, gonna make this bigger, bigger, bigger. W. W is who is connected to the system. We saw a little bit of this last classes. You have the user, the teleterminal, the IP address from which is connecting from, the login time, how long it has been idle, percentage of CPU, okay? First command. Actually, this should be your first command when you log into a computer. You log in, who is logging with me, okay? That's it. After that, you can do the command last, which is going to tell you all the last logins done in the computer. So you do last, enter, and you will see a long list, maybe not so long in your Docker. This is my Docker, that's why. We're saying who connect to from, and which user it was, and things like that. Sometimes you have if it's still logged in, like these ones, right? And sometimes you have like, hey, it's gone but didn't log out. Maybe the connection was closed or killed, okay? So last is your second command of the day to actually find who is in your computers. Actually, this command is reading some log files. So let's gonna briefly look at some log files that you can go and check. These are binary log files, which means you cannot just go and open them with an editor, but they are there for you. The first one is var log utmp, actually var log, so it's like a full accounting of the current status of the system, booting time, uptime, user logins, logout. It may not exist in your computer. Then you have var log wtmp, that's also a binary file, and this is a historical file to record every login in your computer, okay, including SSH. Very fast to remember. UTMP is for users, WTMP kind of for who, and BTMP for bad, okay? Those are the binary files in your system for login. It may happen that computers are rotating the logs. That means that every day or week or something, there is a process called log rotate that goes through your logs and start rotating them. That's so you don't have a huge log there forever. So every hour or day or something, they rotate. If you have rotated logs, usually they end with .1, so you can force the reading of specific log with -f, okay? In this case, you don't have this command because I think you don't have the file because it's not rotated, but if you have it rotated, it should be there, okay? So let's check the file etc logrotate.conf. Let's go and get into this file, everybody. You can do v, you can do less, I don't care. I will do it here. Less. And in here you will see that it says, hey, rotate the logs files weekly, keep 4 weeks worth of backlogs, that's rotate 4, and then create new empty logs after rotation, and if you want to compress by default or not, and others, okay? So here you can change your log rotation policy, which is a good idea to check. Okay, everybody? Did you see that? I'm gonna give you some seconds so you can go and check your log rotation policy. A lot of tools also like to have a logrotate.d, which means directory, with more configurations. So in this case, you have specific rotation configurations for programs. So if you want to check how the earth log or the apt is being rotated, you can go and check this extra configuration, okay? Perfect. So, yeah, in this case, if you want, for example, to compress the BTMP, you can go and edit the logrotate BTMP and assign here the compress line. And after that, it's going to be compressed automatically, okay? So these are small practices like log rotation, and then we will see how to copy files and everything that keeps better and easier to check the security of a computer, which means when you check, it's going to be easier to detect problems and mistakes, okay? It's kind of a hygiene, let's call it. So if you have a compressed log, you cannot do less, but you can actually uncompress it, or you can do directly the tool, like zcat. So zcat or zless are special versions of these commands, cat and less, that can deal with compressed data. So in this case, I'm not sure if I have this one. I'm going to try. and this one is not there, so yeah, you don't have any compressed files, but you can check compressed files very easily. And then we have the last B command, last B. And last B are all the last bad logins, all the times that somebody actually tried to log in badly in your computer. So this is interesting. Please check in your Dockers, but you should have something here. So can somebody tell me like where this is coming from? Who are all these students' Dockers that you have that in the logs have all the usernames? Who are all these usernames in here? How are they in your systems? You do have, right? Yes. From the last lecture, we were brute forcing, right? These are the brute forcing attempts, so you can see there what's going on. Actually, if you pay attention, there may be IP addresses from the internet. And that is correct, because the SSH ports of your Dockers are open to the internet. That's why you can connect from home. So you may expect that from time to time, somebody's finding these ones and actually really brute forcing from the internet. I don't have it here, maybe. We'll see. Yeah. Oh, yeah, from time to time, I have some of them, OK? So you can go here and say, oh, who is trying to log into my Docker from the internet? And there you go. And the last one we are going to be seeing is called last log. And last log is a very nice summary of all the users in my Docker, one by one. And now it's telling me when was the last time they log in. And this is very nice to know. All the users in my computer, when did they log in, right? When was the last time? And if they never log in, you can be assured, oh, that's fine. Only root login in this computer, OK? There was no passwords put in these users. Questions? So far? First stage? Are we good? Yes? That was easy? Yes? Sorry? Why are the users there? What do you think? Yes, the question was, why are those users there if they never log in, right? So, what do you think? What was your name again? Georgi. What do you think, Georgi? Is it a mistake? Do we have an attacker? Somebody got in and created users? System users, exactly. So those are users that certain applications or processes inside the computer need to operate, because you don't want to run all your processes and applications with the same users. That's bad, 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 bad. Don't do that. Windows, don't do that. So the problem is that you give specific users to specific applications, and then you can control what they can access, how they can access, when they can access, files, folders, and stuff like that. And it's easier to delete everything. So here you have, for example, the typical user used by Apache or web browsers, right? The user that you have for doing your backups, that usually is a kind of a special user, and others, okay? These ones are not meant to log in, and actually should never log in. And we will see today that they are disabled to log in, which is correct, okay? Okay, what is the disadvantage of using these commands like w, last, and last log? Who can tell me? What is bad about what we just saw? If you are in the mentality of the attacker. That, of course, you are, right? Somebody?
If I hack the computer, the owner is actually trying to look if I got in there somehow.
Yes. And why using these commands for the defender is bad?
It exposes the fact that I'm looking into someone and they might flee or flee on their tracks, so I don't...
No, but that's good for the defender, right? As a defender, I found you.
Yeah, but if the attacker knows that I'm looking for him, he might start being a bit more careful, clean up more a bit under themselves, so I can't...
Agree. Yeah, agree with that. Agree with that. But you don't know, as an attacker, you don't know exactly what I'm doing, maybe, right? My point is, what is wrong with those tools that are bad for me? And you have something there? What did you say?
They are just reading files which we can modify.
We can modify. Those are logs, right? Bar something UTMP. What's stopping the attacker for deleting that file? Or modifying that file? Or changing the file? Actually, the only thing stopping the attacker is being or having a user with enough privileges. Usually it's root. So if the attacker has root access in that computer, as you do, tough game. This is a tough game. I'm not saying that you lost as a defender, but are very close to loss, right? Very close. Like, if an attacker has root access, they can do many, many things that are gonna be very hard to find out. If they don't, then they cannot modify these files, and then you have the power of defense, okay? So, let's jump into checking the existing users in the system and password database. So that is the etc shadow file. So there is a file called etc shadow. Please go and get it. This is the file, okay? And you have lines, one for each user, and you have columns separated by the columns. So you have some column here, columns, 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 and some columns at the end, okay? So let's see what are the format. All of these are the official users in your computer that you have passwords assigned. So the first column is the user login name. The second one is the ID of, okay, so the second one from here to here is the whole encrypted password, okay? Between these two columns, all of that is information for the password to get in. How does it work? Inside this second field, the field separator is the $sign, okay? So now we have $sign as a separator of information. The first information is the ID of the algorithm used. We are going to see later the options. In this case, the Y. The Y is telling me the algorithm being used. The second one, J9T, is the cost parameter for this hashing algorithm. We are going to see in a moment. Then we have the salt. Then we have really the hash of the password. And then we have the days since the epoch of last password change. Remember the epoch, UNIX time, January the 1st, 1970. So this is days since the epoch when the password was last changed. Then we have the minimum days until the password change is allowed. Then we have the maximum days the password is valid. Then we have number of days before warning of expiration. And then some things that traditionally we don't use, like number of days without login after expiration before account is logged, number of days since account was logged, okay? So all the information for each user there. And only the root can see this file, so if you are not root, you cannot see this file, which is correct. And regarding the second field of the hash, the four values, ID, cost, salt, and hash, have these meanings. The ID can be very old, like a 14MD5 or SHA-256 or SHA-512. You can have values like 2A, 2B, which is for the bcrypt algorithm. We are not going to talk about that. Then we have the latest one in Linux, that is the Y for YesScript, and then 7 for SCrypt. I'm only going to talk a little bit about YesScript. So YesScript is an evolution of SCrypt, and it's modified so the cost for cracking it not only affects the CPU, but also the memory. So that means that if you want to crack a larger password, you need more CPU, but now you also need more memory. And that's tough, very tough, right? So they try to make this kind of GPU FPGA resistance, which means that even with GPUs, it's going to be hard to crack. The cost field is actually a parameter for these hashing algorithms that allows me to put how much effort you need to compute the hash. And this is an evolutionary parameter. It means that in years to come, I can tweak it and make it harder and harder and harder because computers run faster and faster and faster, okay? And last is the salt. The salt is kind of a pseudo-random value that is added to the algorithms, so it's not possible to use rainbow tables. What are rainbow tables? Rainbow tables are very simple. It's the list of all the passwords you can imagine, hash. So you hash A, B, C, D, all of them, right? So if you hash all the combinations possible ever for an 8-character password, and that is several terabytes, that's it. You hash all of them. So if you want to know, imagine you get in a computer, you steal this file, Or you go online, underground, deep web, and then you find leaked passwords, right? So usually when you see the leaked passwords, they are the hash. You can crack those. You go, you can crack, and then you have the password. That cracking is very costly. If you have a rainbow table, you just literally search for the hash and say, yeah, I have that hash. It's this password. So to avoid that, the salt actually introduces a very weird thing that is not going to be in any rainbow table. OK? Was it clear?
We have an online question.
Yes.
Is it possible that in the hash part is a second dollar sign?
No. No $sign should be in those characters that don't set the separators. So I wanted to say something more, that it's why? Why do we store the cost and the salt in this etc shadow? Can you imagine that? Why do you need them stored there? Exactly, for the login process, right? So the login process is kind of a hashing back. So you are giving me a password, and to check that you are giving me the correct one, I need the original salt I have from the file, the original cost I have the file, then I hash, 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 and if the resulting hash is the same as I have in the file, then I allow you to log in. That's the methodology, okay? That's why I need to store them there. So if you start that second field, the hash, with an exclamation mark, this is a traditional way of saying this account is disabled. So login will not happen, but you don't lose the password. So I can enable again the account later, okay? Traditionally, you can do it with that. Perfect. So next, check the users in the system, but but only details of them. That means we are not root, and we need to check the users in the system. And you can do this in any system that you got access. And that is the etc passwd file. So please, let's go and check this file. etc passwd. I'm going to do it in CyberChef, Cyber Stratolab. etc passwd. And it's a very similar file, users and also separators with columns there, stuff like that. But as you can see, there is no hashing password here. It used to be in the 60s, then we delete it. Doesn't matter, all history. But now, this file, we have other fields. So the fields are the user login. It used to be the encrypted password. Now it's X. The user ID, that's the number used in the files and directories in your hard disk. The default group that you belong to, and then user information can be whatever. Oh, this is root, blah, 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 blah. Home directory when you log in, and the shell I'm going to give you, okay? So if you see the permissions of this file, we are going to see permissions in a while, but if you see the permissions, every user can read the content of this file. It's not a vulnerability, that one. I mean, anybody can read the list of users of my computer. Why would you do that? It's a good answer, but not. Because you log in and say, hey, I'm root or Pepito or something. And the answer is very weird. The answer is actually that when you list files, you need to know to whom they belong. You do ls, and you want to know this belongs to Pepito, root, something. And for that, you need to convert the digit in the file system into the name of the user. And for that, you need access to this file, okay? So a little bit weird, but true. If not, you have no idea who owns the files. So let's jump into, okay, now we got users. Remember our goal. We need to see if our computer was hacked. We check users. We check passwords. Now let's try to find processes. Why processes? Well, because if somebody got into your computer, and even if they're not logged in right now, they may run a program and leave it running in memory. And that's it. So we need to find which processes are running and how to kill them. So we are going to be using, again, the command ps, the parameters all users, display the user ID, process ID, parent ID, and CPU usage. and include processes even if they don't have a terminal, and well, try to print the username that is not there. And if you only did this command, you will find everything, which is super good, right? I like it. I'm gonna delete this for now because it's gonna be too confusing. The problem is that if you want to find users, you usually do grep and find grep root, and you see the process for root. But then you see the grep in the grep. That's why I was deleting it later. Now we don't need it. So those are the processes, and you can see who is the user running them, the process ID, CPU, memory, and the commands. And then you analyze this and say, hey, is everything fine? Is everything, there is something that should not be running? What about that rsyslog-d? What about that one? This one is easy. If you go to a real computer that is not Dockerized, you will see 200 processes, maybe 300. So you have to pay attention here to know if some of them are actually malicious or not. But this is part of how to check. Another tool you can use is called htop. Htop is kind of a top of the processes using more CPU and memory. And you can see here the CPUs, the memory available, the swap, all the tasks, and then who is consuming. And you can go up and down and check them. And you can kill them from here, okay? So htop is a nice tool. Probably the best tool that I know for monitoring resources in any Linux computer is called btop. Btop, you have it here, btop. I want to decrease a little bit so you have a better idea. I know you cannot read that, it's only to see the graphs, but you have a graph of the CPU on top, how much each CPU is being used. I'm gonna log in there so you can see, and you can see this moving. And then you have the same for the disks and the memory, the same graph for the networking, right? If you see the networking there. And then also you have the list of processes, and you can go up and down. So if you want to monitor very fast what's going on with this computer, who is using the CPU, who is using the memory, what about the network, I suggest btop is very, very fast. There are others with graphical interfaces. This one is good, okay? So now that you saw the processes and you identify which processes seems malicious, and I agree that this is tough because you need to know and search. ChatGPT, what is the process called ersd-daemon? I say, yeah, that's fine, it's on the kernel. And what is this process? Stuff like that. So once you identify the process, you identify the process ID. This is the number of the process ID, and we are ready to kill it, okay? So let's try to kill something. The command to kill is kill. We are going to be giving -9, which means sending a signal to the process that means die, but do not stop dying, do not intercept the call. Traditionally, if you don't do any parameter to kill, is sending -1, which is just, hey, please, can you try to die? But the process can say, no, I don't want to die, and that's it. Yeah, it's exactly like this, how it works. There is another one called kill all, which is killing all the process for a specific user. So if you want to kill all the process of the user Pepe, you do kill all -u Pepe. Okay, let's try. You ready for this? Let's kill some processes. So first, we need a process to kill. So what we are going to be doing is we're going to be creating a process that stays in memory and does something, okay? And this is a command we are going to be running. So I'm going to be running the command, and then I'm going to tell you what it does. So that's it. You press enter, and the process is running. You don't know because you should not know. That's an attacker. So what's going on here is that we are using the nohap command. The nohap command is a specific command that tells the process you want to run, hey, do not use the display, the terminal, for your standard output. Do not print in this terminal, because I want you to put you in the background. I want you to run in memory. If you run in memory, you don't have a terminal. There is no terminal for you. There is no display because you're in memory. So if the process wants to write something in my screen but does not have a screen, it may die. So nohap is like, hey, you know what? Whatever you want to print, just put it in a file called nothap, and that's it. This allows the process not to have the problem of the terminal. Then we are going to execute something, in this case, bash-c. what we are going to be executing is a while true, and then we are going to do echo the number 1, and we are going to be storing this one in the file tmp file. Because we are using the double greater than, we are going to be appending in this file, okay? And then last, the ampersand is the special sign that tells the bash that this should go into a background process. That's why when you press enter, you can still type, because you have control of the terminal and the process was taken to the background, okay? So how do we know that it's working? Well, we do the command tail -f of tmp file. So if you do that, you should see the number 1s, and then every 5 seconds you should see a new one. How does tail work? Well, tail is a program that is taking the tail of a file, the end of a file, the end lines, and it's printing them. If you say -f, it means keep reading the file, and every time there is a new line, just print it there. It's one of the most used commands because you can do this in logs of servers, Apaches, whatever is growing, you can see it in real life. Very much used, very useful, okay? So now that we know it's running, now that we know it's work, and if it's not running for you, tell me right now. Internet, if it's not running for you, tell me, but it should. We are gonna try to find it. So let's do the command ps to find it. Just Control-C of the tail. Now I'm gonna do ps-afx. And can you see where is the weird command and process? Can you tell me the process ID? Very nice, 43186. That is the process ID of this process. You should copy or remember this because that's what we need to kill it, okay? And now we are going to kill it, which means we are going to be using kill -9, the process, and that's it. And then you find the process, and actually you have a message from NoHub saying, hey, that was killed. It's not there anymore. So lesson to be learned. You go to your computer, you check users and everything, and then, oh, yeah, there is a weird process there. Let's kill them. And literally go kill them. It's fine. If it's important, it's going to start again. Unless it's your terminal. Yeah, you can kill yourself. Be careful with that one, right? Who is this SSH user? And then you kill it, poof, and you're out. Yeah. Not that it happened to me. A friend of a friend had this issue. So after these killing processes, now our next step is going to be to check the log files, okay? Check the log files. So that means we are going to go to the logs of our computer, and we are going to check by hand anything telling us if there was an attempt or an intrusion. How can we find this? So the file we are going to be looking at first is var/logauth.log. That is the default file where all the authentication is being stored. And we can go and search it. So for example, you can say, hey, can you grab every line that says user in here? Right? So you can do that. And then I'm going to show a lot of data. Sometimes you have lines that you don't want. For example, Chrome, because Chrome, we are going to be talking later about Chrome, but actually needs to log in. So if you need to delete some things, you can delete it here. Okay. From those lines, do not show those. Remember, V means do not show the lines. Ignore the case, uppercase, lowercase, that's the I. Everything that says cron, and then paginate it with less, okay? So if you do that, you will see, oh, receive disconnect from, disconnected user, PAM, session closed for user root, session closed for user root, session open, close, open, and you can check everything, okay? This is a much more detailed log of the activity in your computer. So you're searching for logins in your computer, that's also the way to go. The same with rotated files, the same with compress, okay? If you want to emulate the BTMP log, you can just log, for example, for failed passwords. That's also something you can do. And you're going to have the same information. Well, in this case, nothing. It seems that nobody. What about cyberstat? Yeah, nobody was failed password attempt. Another bigger log, or actually the more important log, is var log syslog. This is the main log of any Unix-like system. and looking at what happened in your system is going to be here. Any error, issue, buffer overflow, maybe if you're lucky, kernel problem is going to appear here. So this command, the cat varlog syslog, is going to show you everything about your system. I mean, everything. Issues with the memory, something that happened with the file checksum of something in the Ansible, right? So this one is a big log. Probably it's very hard to read them one by one, but in an emergency, when you have no idea what happened, something broke, processes are dying, and you have no idea why, you go here, okay? This is the best chance you have of finding something. Actually, if you have systemd in your computer, you can say something like, show me what happened in the last 24 hours, which is probably better. So you can use this command to go back only 24 hours. Not that we can do it here, because journals are not being used. But in normal computers, no Dockerized, you can do that, okay? And the message is also a command that you can use to have the kernel ring buffer logs directly from the kernel. So this is an option there that you can do the message and see. Not in Docker, because in Docker, we cannot access the kernel directly, okay? So, good with logs, everybody? Did you see it? Did you access them? Did you love them? Probably not, but you know they are there, okay? Questions? No? Okay, let's keep defending. You didn't find users, you didn't find processes, you didn't find anything in the logs. What about files that have been modified in the file system? How do you find those? Because if I attack a computer, I need to do something. I need to create a file. I need to delete a file. I need to modify a file, a configuration, put an SSH key, a backdoor, something. I'm doing something. So those somethings may be seen in the file system. So how do you find that? Well, the command to find things is find. That's it. And we are going to be using the -m parameter, which is a modification for time. And we are going to search for files in the file system that they were modified in the last 1 day, 2 days, 3 days, 4 days, or whatever, okay? We want to know what was modified in my computer in the last 24 hours, in the whole computer. And for that, we are going to be using this parameter. So you're going to say, Nasdravi, mtime plus minus a number. Plus means more, minus means less than the end days here, okay? So find is going to figure it out how many of these 24-hour periods ago the file was last accessed. But you cannot say 1.5 days. You say 1 or you say 2, okay? Everything in the middle is ignored. So find, I will be honest, is not the easiest tool to use for this. Like this, a little bit confusing. So if you want to find, imagine that you put -mtime plus 1, okay? In your mind, this may be, oh, all the files modified more than 1 day ago. That is exactly not true. The real meaning is file that has to be been accessed, in this case, at least 1 day ago. At least, so it's 1 day and more, no 1 day and less. You got the difference? Let's see the diagram. The diagram is the best. Yeah. Should be at least 1 day. That is +1, right? So imagine you're here. You're in the now, in the left, okay? You're in the now. If you use m times 0, it means files modifies in this space. That's the last day. Exactly the same as m time -1. If you say +1, it means more than 1 day. So you have the last day, the last day, the last day, more than 1 day. If you say -2, it means in the last 2 days. Got it? Plus, minus, and then the day. It's super intuitive, right? No, it's not. It's like very confusing. So pay attention, use the diagram to know exactly what you want to find. So let's find something. So let's say, hey, m times 0, that means stuff that was modified in the last 24 hours. So I find The second parameter of find is, in this case, the slash. That is the folder when you want to start the finding. This means the whole file system, okay? And then we find everything that was modified in the last day. And then we are going to list those files. We are saying find whatever you find. I'm sorry, find, but yeah. List those, list. And let's gonna do this just to have something. Find dash m times 0.ls. And there you go. Whee! That's everything modified in my computer in the last 24 hours, which is a lot. In particular, we want to ignore the proc and syst file systems, because this is actually accessing the memory shared by the kernel, and that it's not something that you want to modify. Actually, you cannot modify easily, so we want to ignore this. So that's the grep-v and then pipe less, okay? If you run this one, now it's really the files in your computer. Oh, root, oh, test file, oh, configs, oh, TMPs, stuff like that, okay? Got you, everybody? Yes? No? A little bit? Huh? Did they run it? Did it work? Do you have files modify? Perfect. Now they have this file modified. Yeah, this is 24 hours ago. You get the drill. 7 days ago, and more and more. A very specific command that you can do is stat. Stat in etc password actually shows specific information of a file. This is an example in etc password. So you have the, oh, when the file was accessed, when the file was modified, when the file was changed, when it was born, which means when it was created. So you can actually see when each file was done what. Okay? Perfect. Let's jump into the miscellaneous checks. Miscellaneous check because there are things that they don't have a category. We just need to do it. For example, check to find an intruder in your computer, all the past commands, all the commands that the intruder did in the past. And this is very hard because, of course, can be ignored. And we are going to have a class on how to ignore your commands as an attacker. But now you can do things like checking the bash history. That is the history of all the commands execute with your user in that bash. So if you do that, you will see all the commands that were done in your computer, right? The same in the start of CyberLab. Those, well, nothing here because I just booted up. But you can see the history of the command. So if somebody got in using your user, you can go and check what did they type, okay? This is very, very useful. Then you can actually see the installed programs in the computers. Did the intruder install something? Maybe they did. How do you know? So you run this command, which is, remember what I was telling you, the zgrep is a grep on compressed files. And then we are going to find everything that says space install space in the file var/log dpg.log. And there you go. You have all the list of the packages installed in your computer. Okay? So if I attack your computer, I will go install some package backdoor spyware. And if you don't check this, you lost it. Okay? Open ports. If I am attacking a computer and I want to keep accessing the computer, I may open a backdoor as an open port, like NCAT or other ones. So we need to see all the open ports in this moment. We are going to be doing that with SS. If you remember this command, we use it already. And we are going to say, show me all the sockets that are both listening and not listening, do not resolve DNS, show the process that is using the socket, show those that are listening for new connections in TCP and in UDP. So if you do that, you have open sockets and ports in your computer. Very nice command. If somebody is executing something in memory and opening port, you should see it there, okay? Who can tell me what does it mean 000 for the port 22? So 22 is SSH, you have it here, and you have 0000. What is that? What does it mean? This one is open, and you know because it's in the state listen. It's opening the port 22 in TCP, And SSH is listening. But what does it mean 0000? Not localhost, but thank you very much. All network interfaces. It means it doesn't matter how many IPs you have in how many networks. In all your networks, Wi-Fi, cable, whatever, I'm going to open the port. And the same for IPv6. That means 000 in IPv6, okay? So you search for listening processes. You search for any UDP process. Remember, UDP doesn't have state, so any UDP process that is there, you should go. And if you do not which process open it, here is easy, right? Oh, SSH. But sometimes you don't have a process here. And sometimes the tool do not allow you. For example, if you're not root, you cannot see the process opening. So a small trick is to use the list open files, LSOF, a very powerful command. And you can say, hey, go and show me everything that is in this state. Oh, sorry, 22. And then it's going to find every process that is running that is opening the 22 port, okay? So it's a kind of a tricky command that you can go and check. And I'm going to leave the rest for you. And at the end, the last thing to check as miscellaneous are the firewall. The firewall, because the attacker may put firewall rules to block or to allow or to redirect. That's bad. So go and check them. We are going to have an offer of an optional class on this, so because it's a huge topic. And also you cannot do it in the Dockers because the firewall is in the kernel, which is outside. So for now, you can check that link if you want, but have in mind that checking the firewall is important, okay?
We have a question from the internet. Wouldn't an attacker more commonly import payloads using a stager rather than system packages?
Yeah, for sure. But at some moment in time, that's going to be or in the file system or in memory. But yes, like usually you don't want to install packages, but hey, also it depends on the attacker. Sometimes maybe it's easier to install, I don't know. Yeah. I wouldn't install packages, but hey, I don't know. I would check, right, just in case. Okay, ready for the next one? We are defending the computer. We are trying to find who got into our computer. Next step, common backdoors. What is a backdoor? Well, the backdoor is any way that the attacker left behind to come back later that is different from the first one. If first one they log in, maybe they are going to be using an open port. Maybe if they exploit something, they want to have an extra user. So any way that they can log in back is going to be a backdoor, and we need to check for those. The first check we are going to be doing is SSH public keys. So please go to your .ssh folder, authorized keys, and in here you should have authorized keys. Each of these are authorized keys. Like here, look at this attacker. Some Repa Martin something. So like this, you can have people getting into the computer, they put their authorized keys, and that's it. They can log in with SSH without password in any moment. It's awesome. It's like straightforward, okay? And they can do that in your user. So they're not creating a new user. They can say, oh, user Pepe, yeah, use my public key. I can log in as Pepe in any moment. So go and check. Yeah, Veronica several times told you already, please do not delete our keys because we have our keys there to manage your Dockers and to make the class. If you delete, and yes, already it happened. If you delete the keys, we need to put it back, so please don't do that. So after these public keys, we are going to check the process executed login. You know, the computer boots, some things are being executed. We need to check those. As you can imagine, you see that the amount of things we need to check is huge, right? The attackers are doing click, Apache, exploit, and they got in. And as a defender, we are checking every single file in the system, right? But yeah, that's the work. So, execute process at login. These are the usual places. etc rc local is a script, doesn't exist in your Docker, but it's usually there. You have etc profile. You can go and check less etc profile. These are scripts that every time the computer boots is actually executing this. For example, the alias of your LLL command when you do LLL, this one, LL, that one works because there is an alias in these files that every time you log in, this is being executed. So as a user that is attacking, I just go here, I put my line, that's it. My program is going to be executed every time, okay? The same with everything in the profile D, all the folders in there. The same with the specific shell scripts of your bash for your user. That's why I'm using here the tilde. This tilde, this one, means the home user, the home of the user, any user. So I mean, okay, if you are root, Pepito, or Juancito, that means your home folder, and then the bash rc. And you can see this in your computer too. Bash rc, well, you don't have it here, so it doesn't matter. Maybe what installer to server? Do we have it? Oh, I think was, yeah, it's, oh, I make a mistake. Bash rc, thank you very much. Got you. Bash rc. What about in your computers like that? Yeah, there you go. So that one is where you put your own things, right? I like in my console to have set-ov, to have these style keys. So I put it there. Every time I log in, it's going to be waiting for me. Okay? And then we have the official ones. That's etc initd. Initd are all the official scripts of the computer that they need to be run when the computer boots. So if you list those, etc initd, please go and list those. Those are all the official programs that your computer boots when it's booting up. Cron, nfdump, postfix, Redis server, SSH, syslog, Tor, and others. Okay? So you go and you check them, and you open them, and you see what's going on. If you have systemd, that probably you do, you can actually also list all the processes that are being started in the system upon boot by systemd, and that is a different list. And you say, wait, what? Why is a different list? Well, long story, systemd, I don't want to go there. But you need to check and say, hey, systemd, what are you actually executing when my computer boots? That's it. Everything that is enabled is going to be executed. Tor, rsyslog, screen, serials, and others. Okay? Questions? No? Yes? We have a lot of stuff to cover. We need you to get into these ones and have them in mind. Okay? And yes, this is...
I want to add that it's a lot of things that we are telling you, like you don't have to remember all of them, but think about if you're trying to protect something and then you don't have this class, where would you start, right? It's very, very hard to find like, oh, should I check the users? What should I check? So all these things, if you try to see them from a point of view of I have a checklist, and maybe if I go through everything, I know what is in there, and then I can check next week, and I kind of remember, then it's going to be more useful. We are not attempting for you to remember all the steps, but yes, to get familiar with the contents, and then you can come back later and check and see like, oh, there is something new that I didn't see before, right? This is how it works. No one remembers this from memory.
So when you are defending the computer, actually, one of the best ways to execute back my attacker code is using cron jobs in Chrome. So what is cron? Cron is a process that is in most Unix that wakes up cron and then has a list of things to execute periodically. So cron is the tool that you can use to execute stuff every 1 hour, 1 minute, every August, once every 10 years, or wherever. Like, this is a tool that is the maintenance tools of any Unix systems. For example, I want to rotate all my logs every week. Who is doing that? Cron is doing that, right? So it's a very, very used tool, and it's the perfect place to put my malware code, because I want it to re-execute maybe every day. So the cron is actually seen and managed. We will see later. Okay, actually, we can do it now. Let me see. cron tab dash L. You don't have it. Okay, let's see the format first, and then we will see where to do it. But each line, the last line in this example, only the last line is the real line that cron is executing, okay? That the one that says 17 star, 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 something, something, something. So the format is the following, okay? The first 5 numbers, 1, 2, 3, 4, 5, in here is 17 star, 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 have this meaning. When do you want to run the task? That means, in which minute do you want to run the task? In this case, minute 17. In which hour from the 24 hours? Star means every hour. And which day of the month from 1 to 31? In which month of the year? And in which day of the week? So you select when, and then you just put the user that is going to run it, and this is the command. This is the command I want to run, okay? So cron is very much used for everything that you want to automate. If you want to understand and put a new cron line, I suggest you go to crontab.guru. This webpage is an awesome webpage that you can actually see what happens if you put here a 9, and here a 3, and a 2, and a star star. That means at 3:09 on day of the month 3. So every third of the month at 3 a.m. 09, this is going to be running, okay? So I suggest you use this tool to be sure when stuff is going to be running. And where do you put this? Okay, so the command to list is crontab-L. You can do this in any of our places. There is no crontab from root. And if you want to put a new one, that's crontab-E, which means edit. So, in this case, it's going to make me select my editor. It's going to be Being Basic. And then that's a file that you can go and modify. So you add here your line. That's a completely wrong line, but you put a line. And then cron is automatically going to start running, okay? So for you, what you need is actually to check these lines and to find if the attacker left something there. No cron tab for root, it means for the root user, there are no cron tabs published, okay? Was it clear, cron? Yes? Yes? Internet? Yes? So, if you want to see the cron tabs of all the users, you go to vars poll cron tabs. If you want to see the cron tabs of the system, you go to etc cron tab. Because, for example, the system is configured to have everything that I want to run daily in that folder, everything you want to run only here, monthly here, weekly here, and stuff like that, okay? So it's already prepared. And it's incredible, but the majority of the Linux malware that we know, close to 80-something%, uses cron for persistence because it's easy, it's for every user, and it's actually incredibly reliable. Like it's going to run, no issue. And if you don't check this often, then you may completely miss the fact that your computer is reinfected every hour, for example. So you go there, you clean stuff, you delete, kill processes, and then you say, that's it. And then in an hour, it's infected again. What happened? Well, because it's starting, okay? Questions? No? So, to recap, to check if the computer was attacked, you need to find modifications or additions that were not authorized in any way. And this is hard, and this changes a lot over time, okay? It's one of the toughest part of security. Finding if a computer is attacked, people, we just did, I don't know, what was this, 1 hour on something. This can be weeks in a real system. When you get hired to check if some computer was infected, you need to be absolutely sure. How are you going to do that? You need to read every file, every history, every deleted file, every network traffic. So, tough job. That's why it's also paid very well. If you're a pen tester and you're doing this, it's awesome, right? You want it to do it. I will give some space for questions. First part is over. How to check. And yes, you will have to do this both in the exam and the assignments and the challenges. So have it in mind. You are going to be playing Defender. Did anyone here ever have a computer that was with some intruder? Server, VPS? Anyone having computers on the cloud? Amazon? No? Nobody's having any VPS computer for $0.001 or for free in a hosting provider in Tanzania or something like that? What's going on with these people? People, it's for free. Computers for free. Okay, so if you have, and you say, have you been ever attacked? And you say no, I will ask you, how do you know, right? Because the majority of the times you don't realize until the provider calls you and say, I think your computer is infected, right? Maybe you can leave something there for people to infect. Okay, so go to a break. When was the break? I'm not sure about this one. Look, a lot of stuff we need to do before the break. See, it's here. No, we are fine. Okay, let's do the break. We are back in 10 minutes. 15:36, 46, we are back, okay? Okay, ready? Let's continue, people. Internet, time to go back. Hurry from the bathroom, or stay in the bathroom, whatever you want. I'm not judging. So let's continue, and let's start with password time. So the secret password of this class, if you want to put it to have the certificate of taking the class at the end of the class, it's going to be ostrich. Ostrich. And kind of it's correct, but no, that's a T. Ostrich. Ostrich. I'm not sure if that's correct, probably not. So here you go. That is your password for the day, and I'm not going to say it again. So how to secure your computer? We are up to here. We check, we verify, we found, we kill processes. Oof, we are fine. We are fine. Now, let's protect the computer. How we do that? The first one is hardening user access. Let's try to make something that we control who can really log in. And we are going to start with SSH. SSH is what I believe the most secure login system we have in every system. And if you are ready, or if you can, I suggest you only use SSH. Don't use other login systems. I mean, VPNs, whatever, maybe, but VPNs are many companies, a lot of code, and from time to time, some of them have issues, vulnerabilities, and SSH is such a control process and program and people that they did have vulnerabilities, but I think that less than 3-4 important ones in a long time. So it's one of the most secure systems we have, and if you can only use SSH, do that, okay? So SSHD, that's the daemon, can be configured in etc ssh sshd.conf, or usually, if not, sshd-config in these dockers, and that's what we are going to be checking for configuration. So please go to this one, etc ssh sshd-config. We can see it from less or anyone, any other editor. And we have some lines like permit root login yes, challenge response authentication no, use spam, X forwarding, pre, pa 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 pa. Some of here's are okay, some of other ones we need to delete. For example, password authentication no, it's a good idea if you do not want to have any login that is not a public key. I suggest only use public keys the whole time and try to avoid passwords. If you want this, then you say no password here, only public keys, okay? Use that one. Of course, before doing any modification in any SSH, including your Docker, and please, you can go and try, check that it works before, okay? So please, which means also have a backup SSH connection. In case the first one completely dies, you have one that is already in and you can modify and go back. So try to not be logged out of your Dockers. But please go and experience and try things. And if you are logged out, you tell us and we will log you in, okay? No problems. I usually, for example, create another user, then you put another password. I'm sure that the second user can log in, and then I mess with the first one, and if I break it, I break it. If I not, okay? So, how to choose which users can log in? You can restrict which users log in or not in this configuration by using allow users. So if you want, you can go here, add a line saying allow users, and you put Pepito, root, whatever, and whoever is not in that list cannot log in, okay? The same goes with deny users. You can go and put deny users, and those are going to be the only ones denied. Yeah, this is the easiest way to protect your SSH. The other one is not to let root log in. Usually, logging in with root is a bad idea. We do that in Dockers for you because it's easier. But if you have a production system, don't do that. Always log in with your own user, and always have one user per person logging in, so you can keep track and accountability, okay? And if you need to run something as root, you can sudo and you can run things, but try not to log in as root. So for that, you can say permit root login, no, okay? I'm not sure here, yeah, we have to say yes, so you can log in as root. You can also allow certain groups, like all the SSH users, so you can say, I want to create a group called SSH users, only those are gonna be able to log in. And when you're ready to try, you go and you do init SSH reload. In real life, in real computers, you usually do SSH restart. But in these Dockers that you have, if you do restart, the Docker is going to kick you out and you have to relog in again because you are actually messing with the main process in the Docker. So for you, if you want to do it in these Dockers, you can use SSH reload, reload the configuration, and you're fine. Okay? Everybody? Yes? Was clear? Straightforward with SSH. One of the main issues why attackers actually got into computers we saw last class was weak passwords and default passwords. So how do we force that? How do we harden our system to do better? And that we do with the etc pamd common password. And this is a file that is setting up the policy of passwords in my computer. So if you edit this file, let me see if I can edit it from here. There you go. It's something like that. Please check that you have it and you have everything there. And you can see the policies, like, oh, it's a requisite to do the PAM crab leave. This is because I put it before. The password is PAM UNIX check, obscure, use all, and then deny, and then permit. So you can set up here how is the login process, okay? And what we want is something called the password require PAM crack leave SO. This is a library that can actually do some check-ins on how easy or not easy is to crack your password. So here you can say 3 retries are going to be the attempts to log in. The minimum length of the password is going to be 8. The amount of characters that should be different from the old password are 3. The minimum number of numerals, uppercase and lowercase. So when you are changing passwords, and when you are assigning new passwords, you're going to have these checks and say, well, more than 3 or 4 or 5 characters from the last one. Okay? Yeah. I'm not sure. It's a good question. I never hear that. Probably you can
repeat the question?
Yeah, sorry. If you can have a blacklist of passwords that you can deny all the time, like you cannot put 1, 2, 3, 4, stuff like that. I don't know if you can do that. I will guess yes. I have no idea how to implement it. In my experience, these conditions like minimum length 8, and also these ones here that says obscure, that is going to do check-ins from themselves, already cover the most easy passwords on earth, right? So you cannot put password or 1, 2, 3, 4, 5 or 6 or something like that. But I don't know if you want to specifically block some passwords, how to do that. Yeah, I have no idea. But it's a good one. We can search it maybe. Yes. So small parentheses. If I'm telling you that only log in with your computer using SSH and do not open any other port for anything else, how would you do to actually connect to other applications running in your server that are not SSH, right? Imagine you have a web page in your server, not a web page for the internet. The internet needs access to port 443. But imagine that you have, I don't know, some remote desktop, or you have something that you want to check in another port. How do you access those ports if you are blocking every port from the outside? And the trick for this is what we saw last class in the SSH tunnel. Do you remember the SSH tunnel? We are doing SSH -L. Remember? Yes? No? Maybe? So we were using this trick to force your computer, really, not your Docker, your computer, to go to a local port and then get inside your Docker. So this is the diagram. You are doing an SSH connection. This is your normal SSH client, port, whatever. And what's going on when you do the -L is that you are redirecting everything that goes to a local port, in this case 80, you redirect inside the tunnel, and you send to the port that is listening in the other computer. So in this way, you can have many applications running here that are not open to the internet, but you can access whenever you want. This is the preferred way for many companies even to access applications, right? Oh, I want to have a web page monitoring my computer. Well, I don't want that on the internet, so you just tunnel and you watch it, no issue, okay? Questions here? No questions? Sure? Okay, let's go hardening files and directory. This is gonna be nice. Yes. Oh, thank you very much. Oh, I have stuff to give for questions. Give CCs. Give CCs. Can I give one for an old question? Oh, there you go. So I will give, this is a Domazzi printed, home printed, how do you call it? How do you call when you hang this with stuff like this? When you climb? Carabinier, right? Is a carabinier? Carabina, right? Yeah, that you hang stuff and things like that. Don't Vivero, please don't do this to hang your life on, just bags and stuff like that. I mean, it's hard, but not hard. And I'm gonna give to your question that I didn't answer before. Be careful, everyone around. Heads up. Can you heads up? He's not heading up, and I'm afraid a little bit. Wait. Be careful. Be careful. I'm gonna drop something, okay? Almost there. Sorry. I will aim better next time. So let's continue with hardening files. When you're in your computer, you want to actually make sure that nobody can write or read directories or files that you don't want. Unfortunately, Linux is kind of hard on this. It's not easy to manage files and folders and user. So let's gonna do our best, okay? Question. Imagine you have a hard disk and you go and you put a lot of good permissions, read, write, file, folders. You have very tight everything, right? Does it mean, if this is correctly done, does it mean that these files are kind of protected forever? Imagine I say nobody can read this file, permissions, read, write, everything, right? Does it mean that nobody will read it if the permissions work? Why not? Imagine that sometimes even root cannot. That's possible. You can say, root, you cannot change, modify, or read this. You can do that. And it works. This is not a vulnerability in the system. It really works, the permissions. Does it work? Well, no, because remember that at least people can take the hard disk out and connect to another computer and they read it, right? So you can only respect these permissions if you're running my kernel and my system. But if I just read it like a USB, there is nothing there. So be careful when you think about this, right? Exactly how this is happening. I'm not talking about encryption, but you can check encryption. So let's jump in permissions in files. This is one of my interesting ones. If you go to any folder, please go to any directory folder in your computer. I'm gonna get out of here, right? And if you list stuff, whatever you list, you're gonna see something like that, right? Now I'm in my home folder and I list files. Please be sure that you see some list like that. Let's, for the first time, understand what are we looking at. Until now, we were ignoring it. So those lines, the first column, are the permissions on those files, okay? So first you have the permissions, right, in here, and then we have links to this file, the user owner, the group owner, and then we have the size. By default, we have the last modification time and the name of the file, okay? So here is the number of links to this file, the user that owns, the group that owns, the size, when was last modified, and the name of the file. Okay, everybody? Let's get deep into the permissions. The permissions are separated in 3 groups. 3 letters, 3 groups. RWX for one, RWX for another, RWX for another. R means that you can read the file. W means that you can write the file, and X means you can execute the file. The first group is for the user owner, root. The second one is for the group owner, in this case, root 2. And the third one is for the rest of the world, okay? So here, this means, okay, for the user owner, I can read, I can write, I cannot execute. For the group owner, I can read, I cannot write, I cannot execute, and for the rest of the world, I cannot read, I cannot write, I cannot execute. Okay? Clear for everybody? Questions? No? Okay. So, the first character there, that can be a dash, is telling you the type of file. Regular files are dash, block special files, character special files, directory, symbolic links, FIFO, and socket. That can be the first character, okay? Now, let's check the same in folders. So I have a folder here called set toolkit. You can find any folder in your computer. And let's see what do the permissions means in folders or directories. And they are slightly different. So the R means you can list files in this directory, you know, read, you can list files. W means that you can modify the structure of the directory. What is the structure? Well, the structure is adding files. The structure is deleting files. If you imagine this as a tree, putting new files or taking out files, that is modifying the structure, okay? And the last one, the X, means if you can get in that directory. If you can make this directory your main directory. And that is kind of getting in with CD, for example. Okay, everybody? So, in this case, again, the first 3 are for the user owner, the second 3 for the group owner, and for others. In particular, for W, you also need X, because if you do not have the permission to get in, you cannot get in and modify stuff. So, if you want X, W, you need also X, okay? Technically talking, we are going to be seeing other permissions later, like set user ID and set group ID. That's another class, but in case you know them. So, how do we change all this? With a command called chmod. Chmod, we are going to try. You give chmod, yeah.
I have a question from the internet.
Yes, question from the internet.
On Linux, it's not possible to keep root from reading a file, for instance?
In Linux, it is possible to keep root for reading a file, yes. But you need a special permissions. We'll see later attributes, ACLs, and capabilities, and say Linux. In all of these ones, you may stop root from reading things. But it's a little bit more advanced, yeah. Usually, I would say that if somebody got root access, it's probably possible to do almost everything. Some things you cannot do, details, kernel module, stuff like that, without rebooting, for example, but it's very hard. Usually, with root you do it, and with root you may undo it, okay? If you know what you're doing. That was a very nice, sorry. So, chmod. First, you need to say to whom you're going to apply the permissions. User, owner, group owner, or others, UGO. And then, are you going to add permission, plus, or are you going to delete permissions, minus? And then the permissions are read WX, and then the name of the file. Okay, let's try. Are you ready for this? So, let's create a new user in your Docker called, in this case, Luna. So please user add Luna, or something like that. As you see, we create a user without even putting a password. That's probably bad, but that's it. Then we are going to create a folder called test. And we are going to create this folder, oh, I already have it, in actually the main directory of my computer. Okay? Slash, that means when my root directory starts. Okay, everybody? Now we are going to use chown. Chown is a program to change the ownership. Okay? I'm going to put it here. Change the ownership. And that ownership, we are going to say that is to make the user owner of -test root and to make the group owner of -test Luna. Okay? So this is going to make, look at this. Even before doing that, if I list all the files that I have in my computer and I found test here, test belongs to root and to root. Root. And I want to change that. I want to Luna be able, the group Luna, to own this folder. So sorry, that's incorrect. Chown, that's still incorrect. Chown, the user Luna, the user root, the group Luna, the -test. Okay? Everybody? Now that we have that, we are gonna create a file as root inside the test folder. How do you know that you are root or Luna or anybody? Well, the easiest way is the command ID. If you do ID, you will see that it says, well, your user ID is root, your group ID is root, and you belong to the group root. Okay? So you know you're root. As root, now, we are gonna do touch test file1. What is touch? Touch is a special command that is designed for touching a file, which means changing the modification time to now. But you are actually not modifying it. You're just changing the property modification time. So it's a special one that you touch it and the modification time is now. The hacking part is that if the file does not exist, touch is creating the file. So this is a shortcut for creating files without using an editor. So when you click enter, it's going to create that file called file1. Okay? So let's see. If you do the ll-test, we have now inside the file called file1 that belongs to root and the group root. If you actually do ll-alh or ll of test, you will see the exact permissions. Sorry by the colors here, but the dot is hard to see, but the exact permissions of this folder test, and that belongs to the group Luna. Okay, everybody? Questions? Lost ones? No? Now we are gonna, as root, create a second file, test file2. So we have now 2 files. Now we are gonna say that the file number 2 will belong to the user Luna and the group Luna. Okay? So Luna user now owns the second file. If you list everything, you should see file 2 belongs to Luna and the group Luna. Okay, everybody? Now I'm gonna use chmod to say, look, to the group, that's Luna, take out the permissions to write in this directory test. So if you run this command, it means, hey, to the group, that was the Luna group, take out the permissions to write in that test. So we mark sure now that this part of the permissions, the write, that are for Luna, are not there. So Luna does not have permission as a group to write in this directory. Okay, everybody? Now we are going to change ourselves into being Luna. So this command, I'm not sure if we have sudo. Well, yeah. We are going to be executing a command that is su to change users, and we are going to change into the user Luna. Now, if you do ID, you will see that you are not root anymore. Now you are Luna, okay? Changing users inside your computer. Now that we change, we are going to try to delete the file test file2. Delete rm test file2, and we cannot. Oof, that was a long trip for not being able to delete a file. An example of putting permissions, so some users cannot delete things in other directories, okay? Very simple, straightforward. You create a folder and you protect it. You protected the folder. Did it work? Yes? Questions? No? Okay, let's continue. So, as this, you should check the permissions of usually these folders at least, your home folder for the users, the shadow, the password, all the logs, the main directory, TMP, and the homes. If you check these ones, you are covering like 80% of the places where actually some things can be found, okay? And no break for you now. So, another concept to protect your computer from being attacked is the UMask. The UMask is a system-wide way of forcing a default set of permissions for all the newly created files and directory. So this is a way for you to say, okay, wait, look, you know what? Whoever creates files in this directory, I don't care who you are, the new permissions should always be like this. And it's a little counterintuitive, like a lot of things in UNIX, but it works like this, okay? The default permissions for UMask are 666 for files and 777 for directories, okay? It works that when you want to put the UMask, so let's see which UMask we have now. Oh, I will get out of Luna. Log out Luna. If you do the UMask, you will see that it's 0022. How does it work? It works like this. You are telling the system, hey, when a new file is created, the file male permissions should be whatever was the default minus whatever the UMask I set. So in this case, it's going to be 666 minus, and here I have 022. So if you do this, UMask 027, I'm going to change it for you, right? So please change it. Now you are changing the UMask for this directory. What you are going to be doing is, okay, 666, it's 6 for the user, minus, which is the first number you put, 0. So 0 minus 6 is 6. And I'm going to tell you now exactly the meanings of these numbers. 6 is the second 6, minus 2, it means 4. So it's going to be 4. 6 minus 7, well, it's going to be 0 because there is no minus 1. So at the end, these 6, 4, 0 are going to be the permissions of all the files new in this folder. So let me tell you now a little bit how these numbers work. The R, the W, and the X are assigned 3 numbers. And I'm not sure if I have it here. I think we will see it later, but I will tell you now. The R, the W, and the X are assigned 3 numbers, 4, 2, and 1. That means if I tell you that the permission is 4, I'm saying that this is an R. If I'm telling you the permission is a 2, I'm saying it's a W. I'm saying the permission is a 1. I'm saying it's an X, okay? This is because there is a very fast way of adding and subtracting permissions that we are not going to go here. But in the UMask, right now, if you create a file, if you do touch ASDF, and you see that the SDF, the permissions that you put in here belong to the permissions that are the default minus the umask, okay? So these ones are end up being RWX, nothing for the user owner, or nothing for the group, 0, 0, 0, nothing for the rest. So 0 here, 2 and 6, okay? Very unintuitive, very complex. It's like, why you do that? I don't know why they do it like that. But this is the way that in UNIX systems, you can force every new file to follow a pattern, okay? Yes, if you want to see, hey, can you show me when I create files here, how would they look like? Can you tell me what is going to be happening? You do umask dash capital S, and it's going to tell you, oh, yeah, whatever you are creating here is going to be RWX, RW, and nothing extra, okay? According to the permissions. Tough one. That was tough one. Okay, let's go into file attributes. File attributes actually are a very nice modern way, when I say modern, I mean the 90s, where we are actually adding to files metadata. And metadata is extra information related to the file. Usually we have the file, the name, dates, when this is access modified, we have permissions, and that's it. This is a new thing. And the attributes are, I'm going to create a file, something called like file test in here. Please do touch the file test. And then you can use ls attribute, list attributes, ls attributes to see the attributes of a file. And the attributes of a file are these ones in here that are dash, dash, dash because they're not there. And then we have one. What are the attributes of a file? The attributes are actually very interesting. And you can tell a file, this file is append only. Why would you put a special attribute to a file that it's append only? That means you cannot go and delete files, delete lines from the back. You cannot edit with an editor and actually delete something. You can only add. Why do you think we need these permissions? And I have another carabiner for you. Logs, very well. Yee, be careful. Oh, so I'm still not close to that one. I'm sorry. So yes, for logs. Logs are special files that I want to add, I don't want to delete, so append only. You can force files to be compressed in real time without actually using by hand the compressor. And this one is very interesting related to the question on the internet. Call it immutable. When you set the attribute immutable, that file cannot be modified. That's it. I don't care if the permission is write, read, X. It's not respecting the permissions. This is lower. So when you say as root, this file is immutable, I don't care. I don't care which permissions you put. You are not going to modify until I take the attribute out. And then we have for journaling, no compression, do not update the access time, do not copy on write, and the one we have here that is extends the map blocks on disk. So in the one we have here, E, it means use very long blocks on disk, so it's actually much more performance the disk, okay? So let's use it. Let's change attributes. And for that, we do ch attribute plus whatever we want. In this case, we are going to say, hey, I want you to compress in real time. And then you list the attributes, and you see the C as an attribute, okay? So you have permissions for files and directories. Now, in your arsenal of defensive tools, you have attributes, okay? There are other attributes that we don't see here. You have here the full list, like no dump, asynchronous, and others. They're not super important for us, but if you want to see the whole list, you can read it from here, okay? Then, yes, I wanted to say that some of these ones are not going to be working in Docker, like immutable, because the Docker daemon is not authorizing to use them, okay? So if you want to do that, you need to run Docker with the special permissions that we are not doing. So that's for home. If you want a Docker at home, you want to give these permissions and attributes, you can use this, okay? So that's a side note. So in the case of other attributes, let's try, for example, the access time. So you can create, again, a test file. Probably you have it already there. Let's try together. We are going to list, look at this, list the properties of a file, but we want to see the time of the full time in ISO format when the file was accessed. So if you do that, this time here, fully with seconds, microseconds, and milliseconds, and nanoseconds, that one is the time when the file was accessed, okay? So let's actually access the file. We are going to do a cut of the file. So we cut, that's it. And now we are going to be listing the access time again, and you will see that it changed. Before it was 2:20:07, and now it's 20:49. So yes, the file access time was changed. Now, let's actually put the attribute plus capital A, which means do not update this access time. Okay? And now we are going to be doing cut again. So let's list, we don't need to list. Let's cut it again. Let's list the attributes again. And you should see that there was no modification. So the attribute actually works. Works. Okay? Did it work for you? Attribute changing? Be sure that you try. You're going to need it. Perfect. Now, there is a new modification to the file system called extended attributes. And the extended attributes, it's very nice because it's a pair of value, like the name, like in a key and the value, right? Like in a key database, you have the key and the value. Here it's called name value. And you can put a lot of different keys and a lot of different values attached as metadata to any file. And that is crazy good because the system is using this a lot. These ones, the extended attributes, are actually used to put security on the system, like say Linux. So there are groups of attributes, for example, the security group, the system group, or trusted and user, and you can actually set this and modify how the actual file is being used. So let's try to see which are the extended attributes and how to use them. Let's create a file called file.txt. I'm going to create it here. Please do it and be sure you have it. And then we are going to be using get file attribute, get fatr of this file. And you're going to see, hey, the file, oh, I already did this before. Let me create a new one for you. Yeah, file.txt, and then get fatr to, okay, get fatr file 2, and you should have nothing, okay? That means no extended attributes in this file. Now, let's gonna add an attribute. Sorry, this is for checking a specific attribute. This is like all of them, and if you want a specific attribute, in this case, imagine that you are checking an attribute called user test. You can access this attribute directly with -n. In this case, you're not going to have it. It's going to say, yeah, I have nothing called user.test, okay? If you want to dump all the values of all the attributes together, you can use -d. But how can we actually put one? So let's use the next example. Now you have the file. The command to add extended attribute is called set f attribute, set file attribute. And we are going to be adding something called user. Remember I told you that the keys, the names of the extended attributes have specific classes. Security, I told you before these ones, remember? Security, system, trusted, and user. And you cannot change these ones. These are set. So for example, the security group can only be modified by the kernel and root, right? The system, the trusted. The user set of attributes, this is for you. So here we are saying, hey, look, we are going to set as an attribute in the user group something that I will call a node. Node is my name. You can put there whatever. And the value is going to be, this is mine in this file, okay? So if you do that, that's it. You put something called this is mine. And then you can actually check and get it with -n. And that's it. This is mine. And this is crazy, people, because now we have a file which has a content, and now we have a metadata outside the content that also we can put content, if you know what I mean. So this is a very tricky place. I can store things in here. As an attacker, I can put extra things. You can put comments or notes on files. That is kind of crazy. So yes, you can access these ones. Also, you can print here the base64 version if you want, and many variants. Why we are talking about this? Well, because this is how the system enforces things like the security of the system and who can read or write those files. This is how Linux actually also works, okay? So, I'm gonna do small breathing here. We have a lot of information, right? Attributes and files and folders and permissions and extended attributes and many more. We are gonna be looking at another one now. I need your attention in here. I know it's a lot. After these attributes and standard attributes, we have the last group is called capabilities. What's a capability? A capability is a special power that I want to give, pay attention, not to the file itself, but to the process that is going to be created when this file is executed. Okay? Did you get that? Before we have a file and we put permissions. Okay. We put attributes. Okay. We put extended attributes. Super okay. Now, when we put a capability, it's not going to be for the file itself. It's going to be when you execute this file, can be a binary file, can be a Python file, I don't care. When you execute this file, the resulting process in memory is going to have these specific capabilities. And the capabilities are, in traditional ones, specific things that you want to give because the original user cannot. So, a long time ago, in a galaxy far, far away, we have privileged processes or unprivileged processes, which means you are root or you are not root. That's it. It was like a very simple definition. You are root, you can do everything. You are not root, you cannot do everything. But in the meantime, we have stuff. For example, I want to give one specific process the ability to read from the network, but I don't want to give the ability to destroy my hard disk. So this middle ground, we start putting with capabilities. How many capabilities we have? Well, we have some. For example, the capability netadmin is if you want to give network-related operations to your processes, right, like the firewall, routing tables. If you have the net bind service, is the capability to actually bind the socket to some privileged ports like 22, okay? So you want to give specific powers to specific processes. Let's try. How do you see the capabilities? With getCap. So getCap, user being ping, and then you run this and say, oh, look, ping has the capability that's called net raw. That means network access to raw sockets. Raw sockets are a specific type of sockets that you can actually create packets by yourself without the operating system. So you are giving this ping command the capability to create a packet in there that actually does not follow the rules of the layers in the operating system. So that is one special capability for ping. If you want to confirm, right, that this is a capability, you can actually say, hey, if you give me the capability in the security group's capability of ping, what do you get? And that means that, if you remember, this is how you get the extended attributes. So the extended attributes that we saw before, we put a note as a user. The security group is meant for capabilities, okay? So capabilities are put in the files by using extended attributes. So let's try to give a file permission to use raw sockets in the network. Remember what is a raw socket? It's a socket that instead of asking the operating system to manage the TCP headers, to manage the ICMP headers, to manage the IP headers, right? Instead of saying, oh, Python import socket, socket, create, and send, in a raw socket, you have the ability to put every part of the header by hand. You can put whatever you want in those bits. So it's a special capability. So let's try to do that. And that means we are going to create a new file, touch test file. We are going to set the capability raw sockets, test file. And then you can try to see the capability, right? With get capability. And say, oh, we just put the capability. For example, if you install TCP-dump, the sniffer, network sniffer in your computer, and you want this to work in the network, you need to give this capability. So the process itself can do it, even if your user cannot. And if you want to remove it, you just use -r, okay? Capabilities, we're good? Perfect. Another way of using the extended attributes, one is capabilities, the other is access control list. So access control list is the most high-level way, the most modern and complex way we have to actually take control of who can do what in our file system. Because if you ever play with file system, you will find that having groups like SSH users, internet users, and then putting users there, it's not enough. Sometimes you want to correlate who access what. And then you need the access control list. So ACLs, access control lists, are also implemented as an attribute. So that's the same as before. And if you don't have them, you can install. But in our Docker, this is installed. You don't need to access to these tools, but just in case. Okay? So let's go directly to these ACLs. Let's create a file, touch test file again. And let's gonna get the extended attributes. In this case, the get ACL, get file ACL, is the extended attributes for the ACLs. And it's telling you, look, the file is this one. The owner is root, the group is root, and then we have, for the user, RW and nothing. For the group, read, and others, nothing, okay? The same information that you have in the permissions. Okay, everybody? So far, no modifications. The ACL matches the permissions. So let's imagine a situation. You are a super hacker group, super duper. So you are in some computer and you have your own files that only your group can access, right? So only root can access these files. But from time to time, you want some other user to read your files. You want to share with them. But you don't want to put this user in your group. It's not a super hacker. It's just somebody. So how do you do that? Let's try to do it, okay? First, we are going to create a folder called TMP only hackers. So create this one, please, TMP only hackers. Oh, I already exist for me, of course, because I was trying. Okay, TMP only hackers. Now, we are going to check the ACLs of only hackers. And it's like, yeah, your normal ones. Root can do everything. The group can do read and get in. And the rest can do nothing, okay? Now we are going to add a user called newbie. So add user newbie. It's going to be asking for a password. I will put a password. And it's going to be very simple. It's going to complain. I don't care. I keep typing. And then it's asking me the full name. I don't care. Room number. Do you know why room number is here? This is very weird. In the 60s, systems were shared by people, and those people were usually students in universities, where the first UNIX systems were created. So the typical case was students that have to access, and the students live in some room. So you have to put, yeah, I'm living in room 235, or stuff like that. So you have the room number there. But room number, work phone, home phone, other, we don't care about that. And then is information correct? Yes, and that's it. We just created a user. This time we put a password, okay? Please do create your user, put some password. Got it? Perfect. Now we're going to use Tmax and create a new session. You remember Tmax? Yes, right? Use it every day. And the session is going to call newbie session. So please create a Tmax. Okay. Everybody? And now we are going to change from the user we are now, which is root, again into newbie, like we did before. Now I'm going to use indirectly su-newbie. And if you check ID, you should be newbie. Okay? Same in the start of CyberLab, same on the internet, same for you here. And if we have questions from the internet, okay? So now we are going to create a folder, a file inside TMP Only Hackers called mine. And it's going to say permission denied, which is good. Or you cannot do that because we are now newbie. We confirm newbie cannot do that, okay? Now, get out of Tmax. Remember, Control B, at the same time, Control B, and then you let both go, and you press D. Control B, D, and you get out, okay? Now we are back in root. So far, we create a folder, we create a user, and we are ready. How do we incorporate this newbie user to be able to play in our directory? And that is with the set file ACL. We are going to modify to add the newbie user with the permissions RWX, where in TMP only hackers. So if you do that, and then we can check the ACLs again. Now we have a very weird thing. We have, oh, the user can do RWNX, the group RX, they have a mask, others nothing, but we have a new one that is the newbie user RWX. This is the first time that in Linux systems we were able to put ACLs directly on the files, which until not long ago, like maybe 15 years, 10 years, was not very easy to do, okay? So now that we have this, and now we have a special rule for newbie to get in, we can try. So go into your newbie session again, Tmax A, go there, and now if you do the touch again, you should be able to do it. And now newbie can create files in that folder, okay? The weird thing is that if you get out of Tmax and you list the TMP only hacker with your LL, right? LL TMP only hackers, right? You will see like kind of the newbie is the user, but this is not completely correct because the LL tool, the LS tool does not know how to read the ACLs. So there is much more information there than actually what LS finds. So if you are not aware of this and you don't do the getFL, you don't know that actually there are other owners, which is root, and what can it do. So yeah, the capabilities and the ACLs evolve and the tools didn't correctly a lot, okay? Questions? Yes, so that's very good. In this case, when you go to this folder or file or whatever, you have a user, like newbie or Pepito or something. So if there is a rule for your user in particular, as a user, that's going to apply, right? Now, if this is not your user, or you cannot do that, it's going to check the group, because maybe you believe, sorry, no, you belong to some group. So if you're in the group, whatever, starter, and starter can read, then it's going to check that. And if not, it's going to check what can you do as the rest of the world, like completely unknown, right? Yes, exactly, yes. So the root, the owner is still root, the group owner is still root, these are the permissions for root, these are only for newbie, and then these are for the group and for others, okay? And I wanted to say in relation to this that you can also make users not do stuff. So you can say, look, for the evil user, just delete everything. So you can actually take out people from specific groups. You can have a group where evil is part, and they can say, but evil cannot do stuff in this order that you were asking, right? It can. You can be the owner. Sorry, yes. It's possible to be the owner and not have permissions. Yes, you can actually be the owner of something, and then you delete the permissions, and sometimes, depending if it's a folder, a directory, a file, or something, you may not be able to put them back, right? That means that you can create a file, imagine, and you can give this file maybe to somebody else as owner, and then you cannot recover. Of course, what you cannot do due to security problems is, imagine this, I'm an attacker. I create a file with some malware. I cannot then give and put root as the owner of this file. I cannot make the file be owned by root because of security concerns, right? It's mine. No, you own it. So in this case, imagine, right, I touch something there. So in here, root is the owner, right? But also I can say, hey, look, in the permissions in here for the user owner, I don't remember the self, it doesn't matter. I can delete all the permissions for me. Now, because I'm root, usually when you are root, those permissions are not checked to you. So if I can now edit the file, imagine I want to edit the file, and I want to add something, it's going to work. But I should not do that because I don't have right. But because I'm root, it's a special user. If you do that with Luna or a user, it's not going to work. It's like, yeah, you own it, but you don't have right. Okay. And I wanted to give for the previous question, are you ready? I have the last carabiner. This one, I can do this. Look at that, like a charm. You have more? What's going on? Okay, so yes, I can, what I wanted to say, yes, put and delete user from here, yes. And also you can force the default users and groups inside the specific directory. This is super good because sometimes I have a folder and I want all the files, I want you, all of you to go to my folder and create things. But I want all the files that you create to belong to me, because if not, I lost control. So you can also do that, right? In this case, oh, look at this one, it's like violet, that is nice. In this case, if you want to force users of the new files, right? So let's try something. Let's touch in TMP only hackers the test one. There you go. Okay, so when you list, you see that test one now belongs to root and belongs to root. Okay, so imagine I don't want that. I want the new files to belong to somebody else. So what you do is you set the ACL saying, look, for directories, I want in a recursive way, so all the directories here, I want to modify that the user, okay, for any user ID, doesn't matter the user ID or group ID, I don't care which one, for the user that owns, the permissions are going to be R, W, and X. X is here capitalized because it's a special X. So that means, well, you are doing this recursively, and probably you don't want to just add execution to everything because it's bad. So that means if the file already has execution, leave it there. And if it's a folder or directory, don't put it. Okay, so it's kind of a protection. And then you can say, and also, comma, and also, make the group don't have the ID, don't have any permissions. And make the others, without an ID, again, not to have any permissions. So dash and 0 are the same. Okay? Got you there? So you execute this, and then you create a new file, touch. Did I have test 1 already? Oh, I can have test 2. And then I list again, and then the permissions are different. So you can force different permissions for all the files that are being created, exactly like we did before with UMask, but in a much more modern and coherent way. Maybe we can just change to this one and forget about UMask for the rest of the classes. Was it clear, people? Do I have still with you? With me? Huh? Ah, break? We are in a break. Okay. Oh, we are break. Yes, here we are. See? Just in time. Okay. Let's do a second break so you can think about this and relax a little bit, and see you at 56, okay? And I will keep this for the passwords, the questions later. Okay, we're gonna be starting, okay? So, ready? Let's gonna continue. I'm ready with a lot of carabinier for questions. So, what are my questions? If you don't ask any questions after the class, I just put them in the trash. I destroy them, okay? Yes, yes, so if you want them, ask questions. So, we are gonna jump now into, okay, so we are protecting a computer. How can I delete users? I have unwanted users in my system. How can I delete them? And this is a little bit trickier than you think, because yes, you can delete the user entry, but what about the files, everything that the user did? Imagine that you're removing a fake user that an attacker created in a computer. How do you do that? So, first is that we need to be sure that we copy all the files, because if this is an attacker, you want to keep a registry of everything that the attacker did. So before deleting, you just need to back up. How we are going to back up that? So let's going to create a user with user add. For some reason, I have a user ID in called Luna again. I'm not sure. Yeah, I already have Luna. So if you already have Luna, awesome. We are going to be creating a user. Now I'm going to be touching a file called Luna Lunera in the dash main root folder. Okay. Now I'm going to give this file the ownership to Luna user and the ownership to Luna group. Okay. That's it. Now this file belongs to Luna user and Luna group. Now, as a defender, you say, oh my God, there is a Luna user. What should I do? What does Luna own? So you can do find from the dash folder, dash user Luna. And this will show all the files that belong to Luna. Okay? If you do that, you will see a lot of stuff. Actually, I was not expecting that. A lot of stuff, including test and Luna Lunera, okay? Now, the backup you can do with a small magic where you do, okay, find in the root folder all the files belonging to Luna, and for each of them, execute the tar command. The tar command is a special command that creates packages of files. Packages of files. These files are .tar, so you can create a file that inside has many other files. And if you don't know, the T is coming from tape. Tape, because in the old days, we have magnetic tapes. Still now we do, but magnetic tapes that you need to store things. And when you store in the tape and you read from the tape, you need to do in these very specific and organized groups of files. So tar is coming from that. Now we use it to create kind of a bundle. This is not compressed, so this is not a zip, but it's kind of closed. Imagine a zip without compression, right? We are going to create a tar called backup.tar. Inside, we are going to be putting all the files that belong to Luna, okay? So there is a little magic here. This is execution, and the curly brackets are going to be replaced with every file found by find. The curly brackets are going to be replaced by every file found by find. So find is finding, and then executing tar, and inside is going to be putting all the files. Okay? And the / semicolon is to escape the semicolon, so actually it's not read by the bash, but goes to the command. So if you do that, you're going to be running, lot of things, I don't know why so much. Running. Wait for it. Wow, that's a lot of files. I'm not sure why I have so many things in here. Yeah, I don't know. Okay. And when it finishes, you will see that you have a file called backup.tar. Okay. So that's going to be the backup, still running. You are going to be backupping the files because you are the defender. And now you are changing the user and group ownership of the files to you because you don't want the user Luna, which is the attacker, to actually be able to read this backup, right? This is what you want to do. So, wow, that's a long one. I'm going to stop it just in case, but it's not going to be here. So you change the ownership of these ones, and that's it. Now you have a backup that only you can use. Usually to my backups, in the case of attacks, I also do not allow the rest of the users to be able to change. That's the 0 here. I'm making now the mistake of using the octal notation, but you can do others, delete, read, write, and next. That's the same. So others should not be able to read, write, and next. And that's so I protect that Luna user cannot read it. All of this that we did in the backup is so, and of course you can copy, is so you can do this command at the end. This command is similar to the backup, but instead of copy the files inside the tar, we are deleting them. So be careful in here. But we are going to find all the files that belong to Luna, and we are going to delete them. Okay? In here now, I'm going to be a little bit concerned of doing this because I have so many files that I'm not sure why they belong to Luna, but I will do it without actually the deletion. So if this is me, yeah, I don't know what's going on. Oh, I can do maybe TMP. What about that? I can delete the ones in TMP. That's better. I will go find in TMP and then delete everything that belongs to Luna. Some of those I don't have permissions, okay? And then I want to find the files that belong to Luna. Should be none. Okay? So please try that, at least in TMP, go delete. If you lose control of the computer, it's fine. We can recover for you. Okay? But this is a moment that you can press enter and delete files in a controlled way. Because if you're doing this in a real server, production server, your server, you need to delete stuff. So you need to know how it works. Okay? Questions in deleting a user? Files for now. Okay, now to delete the account, there are many ways. First, you can delete the lines directly in etc password. This is my preferred one, etc password and etc shadow. You just open an editor, go to etc shadow, you press enter, you go to the line where you want, in this case newbie, and you just delete the line. And Luna. Do you delete the lines and you save? That's it. You delete the users. That user will not log in your system. Doesn't exist a user with that name anymore. You also have to do the same in passwd. Remember that these are for the computer programs to read the user ID. So Luna and Newbie out, and that's it. So I like this because I have control exactly on what I'm doing. Of course, you can also use del user or user del, and you can delete this. It's going to be very similar. These are the official ways to delete users. So please go and delete Luna and delete Newbie. Do not leave users in your computer unattended. However, the files in the home folder are not going to be deleted because, well, you don't want to just delete everything there. See, I still have a folder called Newbie in the home folder. So to completely delete this user, you also need to delete this home folder. Okay? If you use the command del user with remove home, it's going to be doing this automatically for you. I prefer to do it by hand to just have control. Okay? Everybody, you delete your users? Sure? Perfect. Now that we don't have users anymore, we protect the servers, the folders, everything. Let's try a little bit of automation because maybe you didn't notice, but this is a little bit of a pain on the ass to do, right? So how do we can do this without going through all the steps? Well, one of the ways to start the checking part, the verification part, is with host-based intrusion detection systems. We are going to be doing network-based intrusion detection systems later. This one is inside the computer. In particular, we are going to be using AID. AID is a very old and still used intrusion detection system that runs by checking every file in your computer. So let's see how we can use it. If you are here in the BSI students Dockers, you have this installed. If you are doing this in the internet, go now and do apt install AID. Okay, so I'm going to go to my Strato CyberLab, apt install AID, and should take just some minutes or less. Okay, so this is because we don't want to actually ship Strato CyberLab with AID the whole time. It's only for this class. So after that, you should have AID installed in the Strato CyberLab, and all of you here should have it in your computer. Okay? So AID, it's based on file integrity. Do you remember the first class when we say, hi, welcome, how are you? And then we said availability and confidentiality and integrity. And do you remember when we said what integrity was? No, that was kind of a flashback. So I have a very nice dinosaur color carabiner ready for the answer. What was integrity? Is integrity? Will be integrity? Should be integrity? Ability to detect changes on the file. Okay, yes, we can do in that one. In a way, it's detecting changes, monitoring changes, or making sure, in a way, that that file is not changed, it didn't lose integrity in a way. I like it. I will take it. How's your name? Honza. Ready, Honzo? Heads up. Heads up. Posor. Heads. Sorry, thank you very much, Lucas. Heads down. Heads up. I'm losing. I don't want to overdo it, and I'm underdoing it. Okay. If you send it back, I will try again. No? Okay. So, integrity checker, which means we are going to be checking the integrity of all the files and folders and permissions in your system. And for that, usually we use hashing. Do you remember hashing? What is a hash function? Anybody? Huh? That is so generic. Give me more. That is like, it's a function. Okay, give me more. What's a hashing? I mean, yes, No, no, this is good. Thank you very much. We take this one, we keep it here. Let's see if there are other answers in the meantime. What does it mean, when function? Okay, you cannot use the same charger to change it back. Okay, and give me more. Give me more. This is like one property. Hashing. So you have hashing function. What does it mean? What is it doing? That's so generic too. So more technical. Okay. Okay, another property. Like the one way, but what does it mean? What? Yeah, you're talking. Yeah, which ones? That's why I want to know. How does it work? Huh? Yeah, but how does it work? What they do? Okay, that's another property. What you're saying that, if I understood, is that the output is shorter than the input. It doesn't have to be, right? If I hash the letter A, the output is going to be the same. So somebody else...
I have an input from the internet.
Go in there.
It says hashing is creating a checksum over an input that will change with every change to the input.
Okay, partial answers. Okay, let's get... okay. Not true. Huh? You have collisions. Yeah, these ones, yeah. You have collisions still. No, the assumption is that they're very rare. That is the security. It's like, yeah, it's not going to happen in the next 100 years. But they are going to happen. So, somebody else? Okay, so let's try to, because probably your cryptographic teacher is watching this, and they are like, so don't say your name, just in case, don't say your name. So you have a mathematical function, you have an input, variable length input, can be one letter or a lot, and what you want is an output that can be some mathematical combination operation of this input that has some properties. So the output should be usually the same length, usually constrained, but the important attribute is that small changes in the input should have a huge impact in the output. So a one bit change in the input should be completely different output. They should not be easy to find this correlation, right? You want maximum entropy or random whatever, right? However, the same input must have all the time the same output. You don't want two inputs to have the same output, but it may happen, collisions, MD5, hello, whatever, right? The one way is that this output, because of course you have millions, thousands, trillions of things that you can input, probably infinite things you can input, but you have a very small range of outputs, right? Because you have a constrained size. That means that you cannot take one of the outputs and kind of perfectly find what was the input, right? You cannot do that easily because the mathematical function goes one way, which means that there is no way to reverse the input and output and get it back again, okay? So we use these mathematical functions to give some content, gigabytes, terabytes, 1 letter, 20 letters, and now put a set of bits that these bits are constrained in size and have some properties like we cannot from the bits find out exactly which input it was, right? This is not encryption, this is hashing, okay? Questions here? Who are giving the carabiner? I'm not sure about this one. I think I will keep it, this one, people. I will keep it. Okay, so file integrity checkers create what AID is doing. AID is running these algorithms like, how was your name again? Vlad was saying SHA-256, SHA-512, or I hope not MD5 or others, and you run this on all the files and folders, and you store in a database. That's what AID is doing. It's creating a snapshot database of this in your computer. Of everything, file types, permission, inode number, user group, blah, 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 blah. So let's try, okay, people? Let's try. Let's run in your computers aid-init, that is to initialize, and that config file. You can do this in the Strato CyberLab too. You can do it, oh, no issue there. And there you go. And I'm also gonna run it in our computer's Dockers. In your computer Docker should be fast because it's configured to be fast. In Strato CyberLab it's gonna take like 30 seconds or something like that. So here after init is telling you, hey, I have a new initialized database in this place. There are 1,400 something entries, and these are the properties of the database. So now that we have a new database, what we need to do is to tell the system, copy, and to tell the system, hey, the new database is going to be your only database. It's going to be your official database. That's that copy. We take the new database we create, and we make it the official database of the system, okay? So you make this copy, back, and Strato CyberLab should have finished. There you go, copy back. Now you can check the system. Now that you have a database of your snapshot of the whole file system, now you can check. And this is what you do when you go into the computer and you want to know if there has been any intrusions. You check the system and you say, can you check the system and tell me if everything was fine? So you run, and here it's telling you, well, actually, yeah, there were no differences. Since the last time you ran this to now, nothing happened, okay? So this is one way of finding. I'm going to make a change for you so you can touch etc something something. I'm going to create a file there in etc. So you can do this to actually try to find the change. The same in Strato CyberLab, right? You can create a file there. And now you can do the check again. And it should say, oh, there is a modification and something happened, right? There was a new entry created called something something etc. And these are the properties in there. So this is good. It means that if you run AID before the attack, after the attack, you can find any file ever created in the file system. Nothing will be missed. And that's awesome, okay? So it's automating, yeah. Skip? Does it skip in a directory? Good question, Jan. So yes, in the configuration file that is here in etc8conf, now, in the case of your Dockers in BSI in CBUT, we modify only to be able to test the etc folder. So if you go to this configuration file and you go to the bottom, you will see that we configure only for this folder, so it's fast. But usually, AID, in the case of Strato CyberLab, if you check in Strato CyberLab, AID, so etc, AID, and then D, is going to be, let me list all of these ones. Oh, I don't have a less. Oh, conf-d. So you have many configuration files, and in these ones you are telling AID, check the var, check the root, check the TMP, check the ETCs, checking everything, okay? So you can go and skip directories, you can configure in any way you want, okay? So after you do this check, you will see some results, and I want to read you what does it mean the results for you, okay? And you can check in your computer. You're going to receive something like this with some pluses, right? And this is a specific format that is telling you what changed. What changed? some there are added entries, removed entries, and change entries. So I will go through these pluses here to tell you what does it mean, okay? I'm going to scroll down, and what this means is that each of these positions is reserved for a letter. So, for example, the first letter is the type of file, directory, file, block, device. The next letter, which is an equal, or it's a less than, or more, or greater than, it means if the file grew in size, or decreased in size, or is the same size. And then you have, for each of those positions, you have a dot if there was no change, plus if the attribute was added, minus if it was removed. You get the point. You understand? Each attribute, you know what having there. And what is the meaning of the attributes? Well, the link name was changed, is the L, the B, the block count has changed, the permissions have changed, the URD has changed, the access time have changed. So you have all the things we saw today, and you have an account if it changed or was deleted or modified for every file in your computer. Okay? Got it? So after you run this, and of course 8 has special rules for log files that are growing the whole time, things like that, you can say, oh, I checked my computer, everything is fine, but now I want to update the snapshot. So what you do is 8 update with the configuration, you run the update, it's going to run again, it's going to create a new file, and then you just copy the new database in the place of the older one, okay? And that's it. You are going to your computer, you check what changed since the last time. Oh, some log files, this is fine, this is mine, okay, update and copy. And in this way, you have a very nice alert system that can tell you that something happened in your computer. Most importantly, when you know you have been attacked, you know exactly what changed, and this is so precious. If not, you're just chasing and finding, and you have no idea. With the 8, you have exactly knowledge of what changed, okay? Specific deleted files that you are not going to find in your file system, right? How do you know if something was deleted? Well, 8 knows. Okay? Questions? No? Yes. Very nice. What do you think? Very nice. So let's try. So the key here is the database, right? var lib 8.a.db. So we need to check that. And who can tell me for a violet, very nice, shiny, silk 3D print, what are the permissions, complete set of permissions for that file? Okay, nice. What should I do to show the whole permissions? Well done. Now? And the rest, what? What about the group? What about the other people? So, answering your question is, if the attacker is not root, nothing they can do. They cannot delete it, they cannot modify, they may want, they may try, but they cannot. That's why you're safe. The moment they are got root, they can delete that. What do you do to protect yourself from an attacker that got root? In the case of a database, right? That is good. What if the file is deleted? You know that somebody did, but how do you protect yourself? You have the knowledge. Yes, somebody got and deleted the file. How do you protect yourself from this? Very well. So you actually copy the database out of that computer before it gets hacked, and then you back up, right? Lukashi, here you go. You ready? Heads down, people. Oh, I'm actually bad at it. I have to recognize. Okay, are you ready? I have one for you. 1, 2, 3. See, I overdid it. Sorry, that's my fault. So I only have one more. So let's jump. We are about to finish, but let's jump a little bit into other two things that are kind of usually questions here. The first one is, don't we have an automated way of checking not only the integrity, but everything, the problems in my computer, what's wrong, what's not wrong, all the things, especially the backdoors? Well, it used to be a program called rootkit. How was rootkit hunt or hunt rootkit? Very, very nice tool that we used to use, and it was with a database of rootkits, and we use it. Unfortunately, it got very old, and it's not catching everything anymore. So we don't have a lot. But we have a company, actually, that is creating this open source software called Linus or Linus, I don't know. So let's try it. This is actually a very nice software. So go to all your Strato Labs or your Dockers, internet, clone this. It's going to be very fast. Then get into this Linus folder, and then you can run it with --Linus audit system. Question, what does it mean, --? And why do we do --? Why don't we do this? Linus audit system. In which ones? In this one or in this one? In this one. In this one, we are not trying to run. Also, we are trying to run. And also with bash. So what's the difference? Get out of here. I don't care. What's the difference between using the // and not using the /? Huh? Sorry, we're using cat, you said? Yeah. Yeah. Ah, okay, okay. And what is it doing? Perfect. And this one? Very well. How was your name again? Tomasz. The green, dinosaur green. Lukashi. Look at that. So the difference, if you didn't get it, is that when you execute something like this, you just go and type something, and you press enter. How is the system looking for that binary? Well, there is something called the path variable. So you actually have a path variable saying, hey, these are the places where you should search for stuff when you have some execution like this. Like user local bin, bin, some. If it's not there, it's going to tell you, yeah, command not found. But if you want to actually execute something that you know is here, it's actually here, but it's not in your system already installed, you have to force it and you say, in the folder that I'm standing right now, search for something called Linus and execute it. Okay? Got you, everybody? Okay, now the one we want is audit system. And then you run it, and it's gonna do stuff. And this system actually is modular, has a lot of different modules that you can develop and the organization can develop, and it's checking everything. Plugins like PAM, firewall, folders, logs, many things. It's going to take some time, like a couple of minutes, maybe 1 minute or two, not a lot. Yeah, and already you can see that found some exceptions and things. And very nicely, what I like about this tool is that it's giving links for you to read about the problems. So actually can tell you what happened, why it happened, and suggestions of what to do. So it's like checking name services, checking ports and packages, doing a complete security of the system. And if it's found, didn't found, not found, or whatever, okay? And let me see if it finishes. Please run, checking the install packages, checking the security repositories, is doing much more than we are doing in the class, right? So in the class, maybe you saw 80% of that, but there are more things to do, right? Yeah, could not find any kernel package via package manager because this is Docker and they don't know about Docker. SSH support, all the options, look at that, all the options in SSH, in secure services, banners, accounting, time synchronization, cryptography, many things, okay? So I suggest if you have a computer, you go, you run this, and you have a snapshot of all of this is wrong. Go check it. Questions? No? Yes? Internet?
So there were some discussions on the internet regarding how efficient is aid in detecting an intrusion. So if you have if you run aid in a cron job and it runs constantly, you always get notified, for instance, after the fact, right? Something that already happened. If you can comment on that.
Yes. So aid is, of course, very limited to specific things. It's like integrity monitor of files and folders when you run the check. So it has a lot of conditions, like the database should be okay, should not be compromised, and then you should run the check, you should read the check, act on the check, update the database. So it's not super easy. And it's true that if the computer is compromised and you run the check a day after, yeah, you didn't detect that. So it's not an intrusion detection system in the sense of checking when the things are happening. It's not an EDR, it's not an XDR, it's not checking the processes, executions, and path. It's just checking the state of your hard disk with integrity. So it's limited. It's not the only solution you should have. Yes, agree. So in here, I'm not going to go through the whole report, but you can see that after running this, I'm going to scroll up. Actually, it's telling you what to do. Harden the system by installing at least one malware scanner to perform periodic file system scans. And even you have links, so you can go to the links and actually check what it's saying. One more sys values or differ from the scan. Enable the audit to collect audit information. So you have different suggestions. Some of them are hard, good information, but it's actually, as far as I could see, very nice in finding things, okay? More questions? No? Okay, so I'm going to leave you the extra automatic analysis of log files. This is a small script that can read the logs and instead of going line by line can show you a very nice summary. I'm going to leave it to you if you want to try later. And we are going to start finishing the class. We are going to have two more things before finishing. The first one is the parish notices. First, we have a new challenge in the Start of CyberLab for you called Intrusion. So for this class, if you go to Start of CyberLab, you will have the Intrusion challenge. And second, it's in this class, for the last 6-7 years, we always refuse to have external people coming to talk as visiting professors. We don't like that a lot because we have a very specific way of teaching with a theory of pedagogy behind this, how we do the class, and it's very hard for other people to accommodate to this style. So usually we don't want to disrupt the flow of our story in the teaching from the first class to the last one. What do we want from you by random classes? However, for the first time ever in the history of the class, we are going to have an invited talk. And this is because we have the honor of inviting and being accepted by Tim Papa. Tim Papa is an incident response engineer, cyber deception strategy, content developer, marketing, cyber operations in Walmart. But before, he was actually a supervisory special agent and ex-FBI behavioral profiler. So he worked for the FBI profiling cyber criminals in real life. So he has a lot of experience. We asked him if he would be able to join in the class that Maurice will be teaching next week about deception. So Maurice is going to be teaching it, and we are going to be having 20 minutes only of Tim giving the class. So I suggest that you attend. He will be online. You can ask questions. Then, and later in Matrix, also online. So that is kind of I'm forgetting something, Maurice? Something more we should say about Tim? Okay. And you can follow him on LinkedIn. He will be very, very pleased. And now the assignments.
Right. So for this week, okay, yeah, thank you. So for this week, another fun one, 5 points. So if you're doing them, you're getting really close to Započet, so good job. So yeah, standard story, it opens tonight at 9. You will be playing again, if you want, for the Pioneer Prize. The assignment will have some 5 parts, each one will give you 1 point. Again, there will be some questions and some flags, but please, now this is the important part for this assignment. Do not block user access by SSH, password, or public key, and do not harden your systems before you finish the assignment. So if you did already something during the class, please revert, because we won't be able to attack you. So something will be happening in your systems. You will have to figure out what, answer some questions, and also harden your systems for the assignments, and then you will receive some flags. That's basically it. Questions, comments?
When we say hardening, it means like changing SSH configuration, locking the system down. Anything that will block us from doing stuff. Everything that you saw today, undo. Okay.
After you can apply again, okay? After the assignment, you can secure your Docker again. So that's it. Please remember the feedback is super important for us. You have the QR code there and the link. Go and tell us something. You can even leave messages. It's anonymous. We have no idea who you are, so you can say whatever you want. And that's it, people. If you don't have more questions, see you next week. And have a beautiful hacking today in the assignment.